Hi guys and welcome back. In this video, we're going to talk about object-oriented programming. Object-oriented programming is a bit confusing when you get started. So if you've never seen object-oriented programming before, just take it easy with the next few videos. Watch them a couple of times if you need to. Ask any questions in the course of Q&A if necessary. We'll be there to help you out. Object-oriented programming allows us as developers to write code in a slightly different way than we would write if we didn't have object-oriented programming. The purpose of object-oriented programming is to make our life as developers simpler by allowing us to write code that looks like what we would work with in the real world if we were talking about, real world things like chairs and tables and printers and things like that, as opposed to code and data passing from one function to another. So that is the purpose of object-oriented programming. And in this video, we're going to look at how it works in Python. Let's say that you've got a dictionary like this one here, which shows some information about a student. Now, clearly, this thing here is not a student. It is a dictionary that has some data. And as we know, programming is all about data and passing data from one place to another and so forth. So what we've got here is some data that is probably about a student somewhere in our classroom or something like that. Then we've got a function that takes in a sequence and adds the entire sequence together and divides it by the length of the sequence and then returns that, so it gives you the average of a sequence. For example, we could use it to calculate the average grade of Rolf. How would you do that? Well, you would have to use the function and give to it Rolf's grades. So you do average student grades like that. So if we run that, you'll see that we get out the value 88.0, which is the average grade. However, there is something about this function which is very important when you are thinking about object-oriented programming, which is that this function doesn't know anything about the student. The function only operates on the input that it receives, and that could be a set of student grades or it could be something else. So when we as developers are talking specifically about a student and we want to calculate specifically the average student grade for Rolf, it is much nicer if we can say, hey student, what's your average? As opposed to get the average of this sequence that could or could not be related to the student. So basically what I want to do is student.average. This is what object-oriented programming will allow us to do. But in order to do that, student cannot be a dictionary, because dictionaries you can't do that on. You have to code your own thing in Python that will allow you to call the average method inside it, and that will give you the average of the student. So it is a very different approach, and it is not necessarily superior, but it is different and it allows you to think of your programs in a different way. So let's rewrite this example here using object-oriented programming so you'll have a look at the syntax. The syntax for object-oriented programming, or to define a class in Python, is to type out the keyword class and then the name of your class. So a class is a definition of something, but it doesn't create a particular student. Here we're only defining how a student would behave. So you can say inside the function, notice that there are 4 spaces of indentation, you can define functions. So you can define a special function called the __init__. So this function name is very important, and it has 2 underscores at the start and 2 at the end, and then you put your brackets, and in here we're going to type out self. Although this is again just a variable name like in every other function, and you can call it whatever you want, it doesn't have to be self if you don't want, but self is the convention in Python. Then in the body of the function, you can define anything you want. For example, self.name is going to be Rolf. And what this is doing is it is taking whatever self is, and it is accessing the name property inside of self. So here we're using the dot notation to access something inside of self, and what we're accessing is the name property, and then we're giving it a value of Rolf. What that means is that when we use this class to create something, that thing is going to have a name of Rolf. So here's how you create a thing from a class. We can say something like student. Notice that now this is lowercase because this is a new variable that we're creating right now, is a student, which is uppercase S because this is the class. And now we're going to tell it to use the class to create what's called an object in Python, to create a new thing that behaves like what this class defines. So when you do this, Python creates a new, essentially empty container, if you will, and it runs the init method. And by the way, it is a method and not a function because it is inside of a class. So when a function is inside of a class, it's called a method. So when you call the student class, notice that this bracket notation here is used to call a function normally, but we can also use it to call a class. When you call that, Python will automatically call the init method for you, and it will create this empty thing called self, and you will be able to modify the name property inside self and give it the value Rolf. The name property won't exist by default, so doing this also creates it, which is quite nice. So once that's done and this self object contains a name property, Python will give you back that self, and student will become a name for the self thing we created, that thing being an object. That's what they're called. So we're using this class through the init method to create an object and assign the name property inside that object to the string Rolf. Then that object is what becomes the value for our student variable. So you can now do print student.name. And here what we're doing is we're accessing the name property of our student variable, which, as you know, is the self that we created earlier on. So that will give you Rolf. And if I run that, you'll see that Rolf comes out. This is how object-oriented programming works in Python. You call a class, the init method runs, and what you get back is the object you created, and in the init method you have the opportunity to set and change its properties. So what we've got here is the name property that we're changing. As well as self.name equal Rolf, we can do self.grades and make it equal to what we had before. Something like that. So we're making the grades property of self equal to this tuple. And then when the function finishes, the class gives back self to student, and now you can print out student.grades if you want, and that property will exist there as well, as you can see. So nothing terribly complicated up till now. There's a bit of data being passed from one place to another, but this is no different to what we had before, really. If you wanted to get the average of these grades, you would still have to, pass them to a function called average, for example, and that would give you the average if you have the function defined. But using object-oriented programming, there's one more thing you can do, which is going to simplify your life greatly, and that is the main point of object-oriented programming, which is to define another method, such as the average method inside the class. And this method will take self as a parameter. Notice that self, again, doesn't have to be self. You can call it whatever you want. That's just the convention in Python. We usually call it self, but you can call it whatever you want. So if you define a method inside a class, all the methods inside the class have to take a parameter, which will be the object that was created initially. You can do return sum of self.grades divided by len of self.grades. Notice how this method here does not take a sequence. It just uses the object that was created up here. So how does Python know that it is to call this method with this data here? Well, here's how it works internally. When you create a new class, the init method runs, and you get this new object placed in student. Then, whenever you want to call this method here, all you have to do is type out student, the class, dot average, and then of course, because this is just essentially another function, you put in there the student object. And what this is doing is it's calling the average method inside, that's what the dot means, inside the student class, so that's this one there, and the self parameter is going to take the value of the student variable, which has that object that was created earlier on that contains a name and a grades. So if we save that and run it, you can see that you get 88.2. Now, this is a little bit verbose. There's a few too many words in there, so Python has a nice bit of syntax that you can use instead of this one, which is to remove the student argument from the average function, and instead of calling the average method inside the class, call it on the object itself. So if you do student.average, Python is going to realize that, okay, student is a student object, so you probably want to pass it as self, as the first argument. So it will do the conversion for you. That is the same thing, one as the other, but this is a little bit shorter, a little bit easier to read. And if you name your variables well, then this is pretty obvious what it's going to give you back. It's going to give you the average of this student. Now you can make it even better, type average grades, say, and that's going to be just a little bit more readable as well. And just to show you that this works, it does exactly the same thing. So this is the key benefit of object-oriented programming. You can define methods inside a class that use the object that was initially created by the init method within them, so that you don't have to keep track of multiple different pieces of data, and the object itself can contain these methods that you want to use inside it. So all the data and the methods are in one place inside the class. Now, the init method can also take arguments or have parameters. For example, we can have a name parameter as well as self. So just to recap, all methods inside a class need to have a parameter such as self so that they can take in the object that you have been constructing. But they can also take more arguments. So here we're going to have another parameter, the name parameter, and then you'll put the value of that parameter in the brackets of the student class call. So we can put here Bob, let's say. So now Bob will become the value for name. Notice that self is given for you, so you don't have to give it a name. This here will become the value for name. But notice that we're not using this name parameter anywhere. We are accessing here self.name, but that's the name property inside self. It is not this parameter. If you wanted to access this parameter, you can do that by doing something like that. Self.name, which is the name property inside self, will take the value of the name variable inside this method, which is this parameter here. So now if you print student.name, you'll see that Bob will come out, because that is what we defined in the init method. Let's do the same with grades. And now, as well as name, we have to pass in a set of grades for the student. For example, we will do this one, give it just a little bit of a different set of grades there, and now we can press play and notice how the average grade changes. The average grade is now being calculated from this set of grades because they are stored in self.grades for this student. So when the average grade method is called, it uses those grades. Remember that you can define multiple students if you want, and that's totally fine. This call here in line 10 will call the init method. It will give you a new object. It will populate self.name of that object with the name argument and self.grades of the self object with this argument, and it will give you this student variable back. I'm going to call this student2. The student2 variable, exactly the same thing, calls the init method, passes Rolf as the name, and it creates a new object and sets the name property of that new object to Rolf and the grades property of that new object to this set of grades here. And what you end up with are two separate containers of data. The student variable, which is Bob and has these grades, and the student2 variable, which is Rolf and has these grades. So when you call student2.averageGrade, again, what Python is doing is it's calling the student class and passing student2 there. So self is student2. When you sum the grades, you're going to be summing these grades here because those are the grades that are stored inside student2. But of course, you can still do student2.averageGrade instead, as that is a bit simpler. Pressing play now will give you 92.2 and 88.2 as the two averages, one for each student. Alright, that's everything for this video. I wanted to tell you a little bit about how object-oriented programming works in Python, how you can define classes, how objects are created, and how methods work so that you can call them with the data in those objects. I hope it's all clear, but if it isn't, please ask a question in the course Q&A. We'll be more than happy to help you out. Thanks for joining me in this video, and I'll see you in the next one.